Irreversible processes only happen in one direction in time in reality. What can be said about the entropy change describing the direction of the irreversible process that can actually happen? So, as we've seen with irreversible processes, the direction that makes sense always had a positive entropy change. So that's actually the answer to this question right there, is that the entropy change would have to be positive. But if you considered, like if you looked at a process and you weren't sure, like if you just wrote down, described in some way, here's a process, and then you look at it and you realize, I'm not sure which direction would actually make sense. I just know, like maybe looking at other conserved quantities, that the final and initial states, or maybe it's the initial and final states because I'm not sure about that, but that the way they connect should make sense. I'm just not sure which way it would actually go. If you calculate entropy changes, that will answer that question for you. And it turns out that is one of the big applications of entropy in chemistry. It's pretty easy to figure out in chemistry based on other ideas what could be hypothetical chemical reactions. But what's often hard is to tell which direction will it actually happen in reality. So if you can come up with ways of calculating the entropy change corresponding to that, which by the way is there's a lot of stuff to learn about how to do that on top of what we're doing in this class. And if you've taken chemistry, you probably know that. But ultimately, if you have taken chemistry, you might know it involves calculating the Gibbs free energy that actually tracks the entropy changes of a chemical reaction in its environment. But that is how chemists can decide if a hypothesized reaction, if they think it will actually happen in reality. So the answer here in a nutshell, though, was that the entropy change is positive.